Hello, everyone. Welcome. Thanks for coming. My name is Regina. I'm from UMA, and I will be talking about the process of designing synthetic assets. You might have seen, if you went to Allison's talk earlier, that today we're launching our UMA Synthetic Asset Token Builder on Rinkeby testnet, where you can build tokens that track the price of anything. And in this talk, I'll be discussing more about the synthetic token builder and how we went about designing the product and deciding which features to include. So first, who am I? That's me. My name's Regina. I studied operations research and financial engineering when I was in college. And after that, I went to work at a bank as a derivative structurer. So that's my fiat life. And now my crypto life, I'm a financial engineer. And I'll go into more detail about what a financial engineer does. But it translates quite well from what a derivative structurer does. And then that's my contact info. OK, so I'm a blockchain financial engineer. I like to call myself a Binance engineer, although I feel like Binance might already have ownership over that. And so I tweeted this out a while ago just to highlight that there is this, I think, burgeoning group of people who are blockchain financial engineers, right? And I made the joke that they're typically, CS or finance grad students, or people who have studied some combination of, I'd say, control theory, game theory, economics, math, finance, computer science, cryptography, some combination of people that all have this interest in what I'll call token design, mechanism design, blockchain financial engineering. OK, so as Allison mentioned, our company is called UMA, Universal Market Access. Part of that means that we want to enable anyone, anywhere in the world, to have access to different types of financial risk. And we think that one of the great things about tokenization is that tokens are freely transferable across people across the world, and then with access to the internet. But as a result, one of the cool things that you can do with tokens is you can give people synthetic risk exposure. So what do I mean by synthetics? So synthetic derivatives are free from the physical limits of physical assets. So typically, if you think about a gold miner, they might trade physical gold with a gold bug, who might trade physical gold with a gold jeweler. And our understanding of the price of gold depends on our records of these individual transactions. So right now, for stock certificates, all of those transactions go through an exchange or some kind of clearinghouse, and everyone has a record of who owns this physical gold, or in that case, physical stock certificates. So I guess now they're digital. But the idea is some centralized counterparty or centralized exchange or clearinghouse knows what each counterparty's holdings of gold or that stock is. So what are synthetics? Synthetic derivatives are free from these physical limits. Alice and Bob can exchange cash flows depending on the price of gold that's reported from all those other people who are doing the work of managing the centralized information, right? But they can exchange cash flows that only depend on those prices that are reported. So what is their linkage to the physical world? Nothing more than the price feed that they're getting from the physical world, right? So what this enables is, again, if you have someone like David, he can sit in the middle of a trade between Charlie and Elise and manage the risk between Charlie and Elise without actually ever having to touch physical gold. Right? So that's why I say that synthetic derivatives are free from physical limits, because none of Alice, Bob, Charlie, David, or Elise need to actually touch physical gold, or they don't need to touch physical gold or even have a relationship with any of these people in order to actually get risk exposure to the price of gold. That's what we mean by synthetic derivatives and universal market access. These people who previously couldn't physically hold gold can now still benefit from the price movement of gold. So I talked a lot about synthetic derivatives, and I explained why that's really cool and they can get exposure, right? So why did UMA decide to launch this synthetic token builder? There are a number of reasons, and I have another slide that explains them. But the primary one that I want to emphasize today is that synthetic asset tokens look familiar. They're ERC20 tokens. They feel very familiar, and they trade on DEXs and centralized exchanges. And they are generally an easier way for, I think, the DeFi community and overall, like in general, the crypto and retail community to understand a synthetic derivative. So in this example, we have, again, all the same counterparties. But instead of them just agreeing to exchange cash flows based on the price of gold, we're going to have Alice own these tokens that are synthetic gold tokens. So if you remember from Allison's talk, she gave a demo where there's a video where someone created synthetic gold tokens very quickly in our dApp. And then if they own those synthetic gold tokens, what they can do is Bob can trade them with Alice, or David can trade them with Charlie. Again, remember, none of them actually had to touch this world. They never had to touch the physical world. But they've created synthetic tokens that still give them the price exposure and the risk of this world.
So for your effectively derivatives, you call them synthetic assets, but they're derivatives. Are you following the ISDA guidelines?
That's a great question. I think this is part of what it means to be a blockchain financial engineer, which is to understand what best practices have been in fiat derivative space. And then hopefully I would love to be part of that conversation in defining what the standards and terms for synthetic assets look like in the crypto space. I think the more that we can broadcast our thoughts and collaborate on this kind of stuff, the more we can create a community of financial engineers, the more we can have an association for these kinds of standardizations. I know there already exist a bunch of these organizations, and I've heard of a couple of new ones at the summit, but I think that's generally like the way that we'll move forward in standardizing.
So you're not following the practices right now?
It's not clear how they would apply to these particular tokens, and I can discuss more of that from a sort of legal or reg perspective after.
The master agreements and closing out the totality of your agreements rather than a single agreement, which I think is one of the big things that ISDA is trying to protect, not a single trade, it's looking at the overall trade.
Yeah, we can discuss that later offline. Okay, so let's discuss again what these synthetic asset tokens are from a technical definition. So they're tokens that are backed by collateral, escrowed in a smart contract, right? And the amount of collateral depends on a price feed. The price feed, of course, as Alison mentioned in her talk, is susceptible to corruption if you have oracles that, well, anyway, we can get into that later. But a couple of examples. In some sense, the synthetic asset tokens that UMA is allowing you to create are not new. Right? You've seen things like synthetic synths or MakerDAO's DAI, and in each of these, you're depositing collateral to borrow a token. So with synths, you're depositing SNX to create a synthetic Bitcoin, or a synthetic other. They have many different markets, I think, but you can do that. With MakerDAO, you're depositing ETH to create a synthetic USD, right? And what UMA enables you to do is you can deposit DAI to create synthetic assets that track the price of anything. So as you might say, well, here you're depositing a volatile asset to create a stable asset. Here we're depositing a stable asset in order to create volatile assets. Volatile relative, of course, to DAI. That's why I say in some way it's not like super new. It's similar to what you've seen before. But we think that giving people the ability to create synthetic assets that track the price of anything will really bring the marginal cost of creating different kinds of risk exposure down to zero and enable us to connect with developers who want to use many different applications of synthetic tokens in their own specific projects. Okay, so I'm going to spend the next couple of slides talking about synthetic asset tokens, and then we'll go into sort of like designing them and also applications. But a synthetic asset token just looks a lot like a lending facility. So in the good case, right, here we've got someone who has deposited the total collateral into their token facility. Then what they've done is they've taken a portion of that, designated it as backing collateral, and issued tokens backed by that backing collateral. They've also got a over-collateralization requirement, so they're required to hold more collateral than the backing collateral. And in addition, they probably will want to top up and include a little bit more collateral rather than just meeting the bare minimum requirements. So in the good case, we have a situation where the total collateral is greater than the required collateral. In the bad case, here what I've shown is where the required collateral is here, but the total amount of collateral only goes up to here. So they're failing to meet these requirements. And there is a process whereby a portion of the over-collateralization they had previously put in gets paid out as a penalty that gets paid out to owners of the synthetic tokens. So hopefully from these diagrams, you're seeing now how these synthetic tokens are a little bit like a CDP, or a little bit like synths, kind of. But the general idea is that, again, it looks a lot like a lending facility, and there's some penalty for being under-collateralized. Or I should say, a penalty for being under-collateralized relative to the minimum, but still over-collateralized relative to the backing collateral.
So if you're going to fail to make the margin call payment to recollateralize yourself, does this become distressed debt sold on the market? How does that work?
Great.
Would you mind repeating that?
Oh, yeah, sure. Okay.
For now, that.
Okay, sorry.
If we can use the mic, because we're recording.
Great. So the question was if, actually, let's make sure I got this right. So you're saying if the amount of collateral is below this amount or below this amount?
Below that amount.
The first one?
The second one. So you would need to do a big margin call to recalibrate, like the CDP. So if you go below certain level, you're basically sold off on the market because your CDP is now null and void.
Great. So if the amount of collateral that and we're calling these token facility owners or token sponsors, they're the people who create these facilities and then borrow the tokens. So if the token sponsor has collateral that's below the amount of backing collateral, that means that from a governance process, we've set the margin requirements and the over-collateralization requirements incorrectly. So right now, that's a centralized process in the sense that I've actually gone through and looked at historical data and set collateralization requirements. At this point, though, yes, we'd have a really big problem. And so the size of this over-collateralization should be approximately equal to the, say, 99.99th percentile move within the time frame that we expect a token sponsor to reasonably come in and remargin their facility and top up their collateral. Okay. So
what happens when they can't meet that remarginalization?
So we'll talk about that. We can talk about that offline. Okay. So synthetic asset tokens are easily adopted, and this is the primary reason that we, again, going back from synthetic derivatives all the way to synthetic asset tokens, why we chose to launch a product that allows people to create these. And it's because, as I said, they're very easily adopted. To token sponsors or the token facility owners, they look like over-collateralized lending. And I've heard this tweet that, over-collateralized lending is the hello world of DeFi. And so that's great. We're going to leverage that. And we're going to try to get token sponsors to understand exactly the kind of risk they have. To traders, they're easily bought and sold on DEXs. They're just tokens, right? So you know how to trade tokens? Great. And then trade these tokens, these synthetic tokens. To developers, they're ERC20s and they're easy to integrate. We don't have necessarily an API right now that the developers have to integrate into their own projects. Someone can create these synthetic tokens, and then all you have to do is support ERC20 tokens in your app project or whatever you're working on. And lastly, of course, why do I like them? I like them because they look like over-collateralized futures or kind of like ETNs. And we can talk about that offline as well. There's a lot of really cool financial parallels between this and traditional financial products. So as Allison mentioned, we built this synthetic token builder to make this easy for people. This is just a screenshot of the website. You can test it on Rinkeby. You'll need testnet, ETH, and DAI, but we have the links to the faucets on the page. If we have time at the end of this, I will actually go through a demo and show you guys how to create your own synthetic tokens. But otherwise, feel free to do it yourself and then let me know how it goes. Okay, so now I'm going to talk about some of the design decisions that went into creating this product. So as I mentioned, I'm a financial engineer, so I had to think about a lot of the different features that people want in these kinds of products. And as I was thinking about this, we realized that there are a lot of features that are really intertwined. So for example, token holders, right? If they're buying the synthetic token, they just want to set it and forget it. They want to buy it, hold it in their wallet, check on the price occasionally, but they don't want to have to do anything else with it, right? That's one of the easiest ways to get retail to adopt something is to just give them this token. And they don't have to do anything, right? So they want to set it and forget it. That to me feels like they want a perpetual product. But token facility owners, if you're short this token, they typically want risk they can easily exit. They want to be able to close out their position when they need to. That sounds like a maturing product. an expiring token. One other way to do it is you could say, well, they both want lots of liquidity, right? Because if there's lots of liquidity, they can set it and forget it when they want to sell it to someone. They can easily find a counterparty. When the token facility owners want to close out their position, they can just buy back tokens from anyone and they can close out their risk. So yeah, ideally we want to find some way to give them lots of liquidity. But if you give them lots of liquidity, that sounds like fungible tokens, right? That sounds like something like DAI, where you have lots of CDPs where the DAI is all fungible. You can use anyone's DAI to close out anyone's CDP, right? They're not individually linked. But that means that you have the negatives of pooled risk. You've got free riders, you've got all this weird stuff, you've got loss socialization, you've got really complicated, nasty stuff here. Okay, so how did we go about deciding which features to include? Well, these are a lot of the questions that went through our heads and that we thought about. So our goal is to define the desired behavior of these financial markets and then define the mechanisms that reach that behavior. What kind of risk will everyone have? So will everyone know whether they're long or short? Will they know if they're levered or unlevered? How will risk be transferred? So are people going to transfer their risk via OTC agreements, via token transfers, via other coordination mechanisms? What's the equilibrium price of the product going to be, right? Are the tokens actually going to trade at the right price, right? Are there arbitrage opportunities? And if there are, do we want them to exist? Are there exit scams? And how will liquidity aggregate? This, I would say, is probably the most frequent question we get, right? Is how do you ensure that there's liquidity for these products that you're creating? And so I call this mechanism design, but for financial products. And there's one more question, which is, what happens if markets are not efficient? I've studied all this stuff, and I can tell you what will happen if markets are efficient and we've got enough capital and everyone has enough capital to execute the arbitrages we want. But then what happens in a space like DeFi that's relatively immature, where maybe markets are not efficient? Are there other safeguards or mechanisms that we can put in place to make sure that all of the behavior we want still can be achieved with the right trade-offs? So going back to this, right? I had to think about all these different features that people wanted, and here are the decisions that we made. We decided that we want token facility owners to have risk that they can easily exit. So we decided to make the tokens mature. This means that token facility owners, because they're really the people who are in charge of creating the tokens, selling and distributing the tokens, we really want to make it easy for these people. Because if it's not easy for these people, these guys can't get any tokens. So we decided, let's make this easy and let's make these mature. Here, we know that both of these parties want liquidity, right? But this is really hard and complicated. And designing a system that works well with pooled risk, with liquidations, with byte fees and keeper fees, that's really hard to design, and that can be really easily gamed. I say easily, I mean, I don't really know, but you can talk to some of the HFT folks that are at this conference, and they'll probably tell you how they can game this system. So this is really hard, and we wanted to make this really easy for people. So if it's easy, we decided to make the tokens non-fungible. So going back to that DAI CDP example, it means that for all the synthetic asset tokens that are like DAI, they can only be redeemed against the exact specific token facility that was used to create the tokens. Let's talk about why we decided that the products had to mature. And this is because the desired equilibrium state was for the synthetic asset token price to trade at the right price. We eventually wanted it to trade at the price feed, right? Otherwise, you can end up with a situation where the token trades at a price just based on demand or supply of the token, right? And how much people want to pay for it. There's nothing actually linking it back to the price feed. But what you can do is you can make the tokens expire and provide token facility owners with this nice arbitrage, I'll call it, with this nice way to ensure that the trading price equals the price of the backing collateral. Let's go through an example. If the trading price is 110 and the backing collateral is 100, right? If it's trading above the correct amount, right? It's trading at too high a price. What can people do? If you're a token facility owner, you can create additional tokens and you can sell them in the market for $110, for more than 100, right? And then this should create downward pressure until the price moves back in line. Because what will happen is you'll create this at 110, you'll create it using $100. You'll sell it for $110. And then by the time the token expires, assuming that the price hasn't changed, it stayed at 100, then you'll collect net $10 over the lifetime of the token. The converse is also true. If it's trading at a price below $100, what can the token facility owner do? They can buy tokens and redeem them against their own facility. You can buy it for 90, redeem it against yourself for 100. This should create upward pressure until the price moves back in line, and you should net collect $10. This looks a lot like traditional financial markets. This is called rolling down to spot.
Excuse me.
Yep.
Is this then similar to how BitMEX does their perpetual swaps, where it's like every 4 hours they will move down to spot, or?
Great question. Great question. So the way that BitMEX works with their perpetual futures is there's a funding payment that's made every 8 hours between long and short counterparties, depending on how far away the price of the perpetual future is from the tracking index. What you effectively have there is an 8-hour expiring future, just like this, an 8-hour expiring token that just rolls over into the next 8 hours. So it's the nice thing that BitMEX has done is they've created something like this. They've just automatically rolled all the counterparties into the next thing, so it feels perpetual, and they've called it a perpetual swap. But in reality, because of the funding payment, and you need that funding payment, it is really like an 8-hour product. If you had something that was perpetual with none of those payments, you could never guarantee that the price of the perpetual future, perpetual swap, would ever converge to the actual price feed. Great question. Okay, so as I said, this looks a lot like traditional finance. It looks a lot like futures roll down. This also relates to another project that Dan Robinson from Paradigm wrote about on September 5th, which I think was like a week ago, called the Yield Protocol. And what he described in the Yield Protocol is another type of concept of a zero coupon bond, and that the zero coupon bond would eventually show you the yield or the correct interest rate for that particular asset. Well, actually, the yield that he describes is exactly what I just said. It's that slope, I mean, not exactly linearly, mathematically, the whole formula, but it is this slope of where the trading price is today relative to the amount of backing collateral that you'll receive at expiry. And Allison showed how, I think she mentioned this in the talk, but I'll actually show you another picture of how we actually were able to create this using UMA's synthetic token infrastructure and actually create something that looks like Y tokens. So here, right, I said it's not exactly the linear slope, but same idea. The yield is this face value divided by the price, so face value being the amount you'll get at maturity divided by the trading price today, which if this is higher than this, should be greater than 1. Exponentiate it, subtract 1, and that gives you your yield. And so the way that you can create Y tokens using UMA infrastructure is you just set the price feed of the token facility to be $1 worth of ETH. So what does that mean? It means that at maturity, you know you'll definitely get $1 back. But because there's the time value of money, you're going to buy a token that represents $1 in the future at a discount today. That gives you your yield. That allows for the price discovery that I think Dan's paper was really looking for. I think this also emphasizes why one of the most important innovations I think in DeFi right now are products that not necessarily are like complicated from a financial engineering standpoint, right? I didn't need to include all that loss socialization and all these complicated like perpetual things. What's really important right now are financial products that are simple and easy to understand so that we can allow for price discovery. What people really want to know right now are yields, right? They want to know what the correct interest rate is for certain products. And making things that are simple like this and then listing them on Uniswap to see where they trade, this actually, if you calculate, it's like a 7% yield, right? Being able to see this on Uniswap, I think, is one of the really important things that's going to help scale DeFi. Okay. The second design feature that I talked about was that synthetic asset tokens are non-fungible. So remember how I said if you own a token facility and it's minting these tokens, well, if this token facility owner sells those tokens to someone else, they have to they can only buy back those tokens to redeem against their backing collateral. Or once the thing matures, anyone holding the tokens can redeem those tokens for this collateral. But in the meantime, while the product is live, only the token facility owner can redeem his tokens against the token facility. So why did I do this? Because if you allow Alice and Bob to have these tokens, which are fungible, even if Alice and Bob have the same parameters, right? It's both the same synthetic, or they're the same synthetic gold token, same price feed, same expiry, same collateralization ratio. Even if we did that, right? And we allowed them to be fungible. What happens if Bob defaults? If you hold one of these tokens, now you know that, okay, Bob doesn't have enough collateral to pay me out. I'm stuck with Alice. These are going to trade at a discount, and that's not good. The whole system's kind of broken now, right? As I don't know, but as you mentioned in your question, right? What are you going to do now that if they're fungible, you know there's like a whole lost socialization that has to occur. But if they're not fungible, then what happens? If Bob defaults, if you hold a token that Bob issued out of his token facility, too bad. You can wait until maturity and then redeem it against the token facility. But at least you know what your risk is. And this is another topic that has come up a lot in conversations about DeFi, is that, oh, it's so complex. Like, there's all this commingled risk, and no one knows, you're doing like CDO squared and things on top of each other, and no one knows what the risk is. Well, that's partly why we chose to make them non-fungible, because here it's very clear what your risk is. And Bob knows exactly how much risk he has. Alice knows exactly how many tokens she has created and how many she owns and how many she'll need to buy back. Sure.
Yeah, I'm just wondering, like, how is it even possible for Bob to default and Alice not to default? I mean, it's effectively the same instrument on both sides, right? So it's just, depending on the price move, then they'll either both default or neither, no?
Well, it's because Alice and Bob each own their own token facility. So Bob can just have not topped up enough collateral, and he just didn't add enough collateral, but Alice did. So Alice had enough excess collateral that she was fine even when the price moved a lot. He did not have enough excess collateral, so he was not okay when the price moved a lot.
That's the bit I was talking about, distressed debt. Because essentially when Bob defaults...
He has the mic. Sorry, I know that they want us to use the mic, so. Anyway, we can definitely chat about this later, though. Yeah. Okay. Last thing I want to show is a couple of applications of synthetic tokens. I want to get you guys really excited about building your own synthetic tokens and also give you some ideas of what people have already built. The first thing I'll say is you can tokenize things and then use those tokens. This is the most basic example, right? And what we did was at ETH Boston, I showed people this picture. And I gave a talk and I said, look, here are some ideas of what you can do, right? You can get leveraged short exposure to Bitcoin without actually needing to own it. We can talk about this offline too. This is really cool. You can create a synthetic CNY stablecoin. And then maybe you're building like a CNY wallet or something, and you can use that there. Or you can do something like you can send Reddit donuts to people, but this time they're backed by real collateral, right? They're not just things that we're trading. They're actually backed by DAI or something. And one of the teams at ETH Boston took this idea and created something really cool. They created this thing called Crypto2Go. And they said, well, instead of converting your USD to CNY, instead of actually trading out of it, and even if you do it seamlessly, right, you're trading out of your USD to CNY, just borrow some synthetic CNY against your USD. Spend this during your vacation and buy it back when the trip ends. Okay, yes, this is really idealistic, right? It assumes that lots of other people are also accepting CNY as merchants. It assumes that you've got enough liquidity there and you've got other people who are willing to sell it back to you. It assumes there's a whole ecosystem. But this is part of the vision for what you can create with these synthetic tokens. The other thing you can do is you can use some DeFi Legos. So there are a lot of other cool DeFi projects out there. One of them is Compound. And they've done something that I also think is really impressive, which is they've created a simple product, which are C tokens, right? They're very easy to understand. They're an interest-bearing token. So what happens if you put C DAI in as collateral? Well, then what you have is you have collateral that's bearing interest. That interest, maybe it's enough to offset your margin requirement, or it helps you top up less, right? Maybe that interest can be paid to the token facility owner. Or you could pay it out to the token holders. So you could just pass through the collateral. You could pass through the interest of your C DAI into the tokens. And then what can you do here? You can offer people something that looks like an S&P future with a DAI interest kicker, right? You can offer yield-enhanced products. And those words, yield-enhanced products, are, I will say, in this environment with negative yields, like if you say that to someone in fiat, they're very interested. So we should talk more about yield-enhanced products. Lastly, just last example I have, you can allow borrowers to lock in a fixed interest rate. This has also been super, super topical. At ETH Berlin, I think I saw a number, at least 3 or 4 projects, all relating to interest rate swaps. So I think there's a lot of demand out there for borrowers to be able to lock in their interest rates. So here's an example of how you could do that with synthetic tokens. Let's say you set the price index equal to the effective interest rate that's being charged on this asset over this time period. Right? So I've chosen a fixed, like, 1-year time period, multiplied by, like, say, $1 of debt, or whatever notional you want to use. Well, then what that means is that over the lifespan of the token, from Jan 1st to December 31st, that effective interest rate is going to be some linear combination of the rate that you've realized over that period and the expectation for the rate in the future. Right? But the cool thing is now you can mint tokens who are backed by collateral equal to this, right? And you have to multiply it by a debt notional to convert it into dollars or DAI or whatever collateral you use. But you set that as the backing collateral for your tokens. And then what you can do is you can sell them to Bob. And Bob is going to pay some price for those tokens, right? He's going to buy them from Alice for a certain price. What we can do is, this is again the price discovery that I was saying. It's not about the complicated product, it's about the price discovery. We can use that price to figure out and back out what that effective fixed interest rate is that he's paying. So what do we have here? We've got Bob, who's paying a fixed interest rate and receiving a floating rate at maturity. That's cool. There are some other details in here about, like, for example, the fact that things have to be fully collateralized. He has to pay all his interest upfront when he buys the token. There's some other issues that if you're a very sophisticated interest rate swaps trader, you'll tell me are an issue. But I think presenting this to people and saying, hey, you can do these kinds of things is really awesome. So if you're a Compound front end, or right, so let's say you have a wallet that integrates neatly with Compound or another lending or borrowing protocol. Maybe an idea for you is you could create synthetic tokens that do this and then make them available to purchase in your wallet as well. Or maybe make it a native feature of the wallet where someone goes in to borrow or lend and they immediately see this token show up, or maybe you wrap them together and you sell that whole thing as a product. Fixed rate loans, right? You could create things like that. I'll also say one more thing. You could then package these payments, right, these cash flows, package these cash flows, or as in fiat, securitize them, package these cash flows together with another stable coin, and you've created a fixed income bond. You've created a fixed rate bond, right? Because you've got the stream of cash flows. Again, I know it's not a stream, it's an upfront payment, but you've got this stream of cash flows together with a stable asset. That's a fixed income bond. Cool. So we have a couple of extra minutes for questions. I hope this has been helpful. You can talk to us, please do. Please come find us. We are on Twitter. You should join our Slack if you have more questions. I'm actually thinking about setting up, like, we've got like a developer Slack and everyone's Slack, and like maybe we should have like a financial engineering Slack if we get enough people. Visit our website. This is me. This is Allison. She's sitting over there in the UMA shirt. Come talk to us. These are our Twitter handles. And thank you. Ask questions. Yeah, go.
Yeah, so I was wondering, if you have any thoughts on why there's so much focus on creating tokens for synthetics as opposed to just creating CFDs effectively, because what you're doing there is you're tying up much more collateral that you would need to just have the margin for CFD. So what are your thoughts on that?
I have two answers to that. The first comes from an adoption perspective, and the second comes from a financial engineering perspective. For the first, I think, as I mentioned a little bit, I think tokens are a much easier way to introduce people to the concept of synthetic derivatives than necessarily a CFD, because if you give someone, for example, a long position on BitMEX, what are they supposed to do with it? They kind of know, okay, there should be P&L that I see, and I should be able to withdraw some margin, but I also might have to top up some margin. From a general retail user, it's quite complicated. So that's one answer, right? The second financial engineering answer is that securely margining a swap, something where both sides have leverage, can be difficult in the sense that because the positions are not fungible, right, because they have each their own individual margin balance, it can be difficult to coordinate how to transfer that risk when there comes time for something like loss socialization, right? It becomes difficult to answer some of these questions when you have a CFD, just because there's leverage on both sides. And fundamentally, unbounded leverage on both sides cannot be tokenized because they represent both an asset and a liability in terms of future cash flows. So that's the other reason that I think those are difficult. Definitely something we're actively thinking about, and that we'll be talking more about in the future, though. Oh, yeah.
I'm curious about the maturation. Is that set by the token facility owner in the sense of this will mature in 1 week, 6 months, 1 year, or is that set by the protocol?
Great question. Let me actually walk us through the synthetic token builder, and you'll see the answer immediately. So here I've got the synthetic token builder. I've already created one at ETH Boston, as you can see. But if I open a token facility, let me just make sure I'm on Rinkeby. Great. So if I select, for example, gold, we've curated 4 different expiration points. In theory, if you wanted to, from a command line, you could use whatever expiration point you want. But again, from an adoption perspective, curating this into 4 sets of expiries should hopefully aggregate some liquidity and give people more confidence that they can go back to the site at this point in time and know when they should be checking. But in theory, you could pick anything. We've just curated 4 that we think make sense for the DApp. Oh. We'll make your way over.
Okay, I have 2 questions. So one is, did you consider not using DAI, but anything else which is more related to a underlying national currency, for example, each XCHF for Swiss franc, for dollars? Okay, there are some other options which are really directly backed by US dollar. I'm not talking about Ether.
Absolutely, absolutely. I think that's one of the, again, it's super flexible.
Because here is again a puzzles, okay, you are trying to build, let's say, volatile asset based on a stable asset, which is based on volatile asset.
Absolutely. We chose DAI for this testnet implementation, but again, it's not testnet. On mainnet, you could use whatever you wanted, and we actually would love to see developers creating versions of this app that are reskinned with a different type of collateral. In fact, I'll say for this Y token demo, for this, we actually changed the backing collateral to ETH, because we wanted this to be $1 worth of ETH in the future.
All right.
So we definitely can use other types of assets.
And could you explain about the expiration? Why we need to?
Yes.
Why there is this feature of expiration? Why the tokens, the backing tokens, are expiring?
Yeah. So did you kind of understand this roll down to
yes,
spot?
this is
Okay.
clear, but I didn't understand why we need these tokens to expire.
So you need the tokens to expire because the only way that you can capture this $10 is by eventually redeeming the token for the actual backing collateral at expiry.
But I can do it anytime I want, right?
So no, right now we don't design it in that way. So we've designed it so that during the lifetime of the token, I think I write this somewhere.
Okay, so if I logged, okay.
During the lifetime of the token, I forget where I put it, but during the lifetime of the token, only the token facility owner can redeem tokens against his own facility. At expiration, anyone holding the token can redeem it against the backing collateral.
Thank you.
How do you guys monetize this? You are going to be doing your own token to
use this facility? How's that going to work?
Great question. Allison mentioned in her talk that there are sort of two components to building decentralized financial contracts, especially synthetic derivatives. One are the smart contract templates that I've walked through, and the other are the oracles that are used to settle margin, remargin, mark-to-market these synthetic derivatives. And so you need both of them in order to actually have a securely margined on-chain system. The way that we're going to monetize is via value accrual, via a token that's used to help support the oracle. So the oracle that settles, or that helps margin and settle these contracts. So that's kind of how the ecosystem fits together. Oh, let's go to the back. No, we'll come back to you. I'll come back to you.
That's all right. I can just do it like this.
In terms of the token foundry, what kind of legal entity do you need to be in order to collateralize and start issuing?
I hear the word legal in that question. I get a little nervous. So for all the legal questions in terms of like, from a regulatory perspective, like on mainnet, like who you need to be, I'm going to defer that to someone else on my team who's more of a legal person. But yeah, definitely a consideration whenever you're thinking about this kind of thing.
So what would happen if there was no expiration? I'm just trying to understand.
Absolutely.
Yeah.
So let's say there was no expiration, right? And I tell you that this token has $100 worth of backing collateral, right? But if I know that only the token facility owner can redeem the token during the lifetime of the contract, I am subject to whatever price the token facility owner is willing to pay for that token. So let's say there's $100 in the contract. Maybe this token facility owner, and I happen to own tokens from that facility, maybe he says, I'm only gonna, my bid is at 80. I'm only gonna buy them back for $80. But you know they're gonna be able to redeem it for 100, right? And so if you have, as a token holder, if you have no way of redeeming the token yourself for the underlying backing collateral, the price of that token is gonna trade at wherever the market decides it should trade, and that might not ever reach this amount. Anything else?
Just on the topic of oracles, I mean, somewhat recently, synthetics got into trouble because their oracle price feed got screwy and cost them a lot of money. So it's obviously a key component of this. And yeah, I'm just curious, in detail, how do you go about sourcing reliable oracles? Great question. I think this goes back again to this kind of like fast DeFi, slow DeFi concept, where I think in a fast DeFi space, yeah, that's like really important. How do you get reliable price feeds for that fast oracle? I think one solution to that problem is to think more in the slow DeFi space. What I mean by that is, excuse me, what I mean by that is like, when it comes time to remargin these facilities, right, and it comes time to figure out where we are on this picture, like how much collateral should be in there, having some kind of delay or having some kind of delay in terms of the price feed, or having some kind of like throttling of how much margin you can take out or add in. Those are other financial engineering solutions to the problem, rather than like technical oracle solutions. So I think thinking about both types of solutions is how I approach that. That's interesting. So in the sense that if there's more money on the line, you basically have something that kicks in a more robust oracle resolution process, or puts in like a buffer time? That's one way to think about it. And we're doing active sort of work on figuring that out too. Cool, thank you. There's one more in the back, in the purple shirt.
So yeah, it's just really a follow-on question. Would that look something like a DAO?
It could. It could. I think there was a person asking about ISDA before, and I think the whole question of like developing standardizations for these kinds of contracts definitely could take the form of a DAO, right? We could end up with a group of people who eventually is in charge of governance for the parameters that are set here, rather than having me do it, right? Like that could absolutely be a potential thing. And I think it'd be a great hackathon project for someone to just write up, like, what would it look like? What parameters would a DAO have to set? What would they have to think about? It's just like more of like a PowerPoint, more consultant type hackathon project, but something interesting nevertheless. Okay, I think we're almost out of time. Should I keep going or?
Over time, maybe.
Yeah.
Maybe this can be the last question.
Perfect. Okay.
So the previous presentation was about like going into $1 trillion economy. Like if you would like to have this, if you imagine that this project could hold like assets or assets under management really in billions or trillion, what would be your like a strategy? I mean, do you imagine that that will be more like physical assets, like, commodities, and in that case, would it be involve like really a crypto market or rather real, let's say, a banking system or brokers who can combine or let's say interact not necessarily with Ethereum but different systems?
Yeah, so I think that goes back to, again, a question of like, do we try to bring the fiat world on chain, or do we create synthetic? Do you bring the fiat world like onto Ethereum, or do we bring more like synthetic derivatives to everyone else? And I think a great example of that is the TBTC project by the Keep Network, where they've tried to make a process where there is, again, over collateralization, but they actually are like, I know custody is not the right word, but they're actually locking up Bitcoin to represent the TBTC, the synthetic Bitcoin. And I think that's like one approach that I find particularly interesting, because it's like bringing things off-chain, on-chain, but in a way that still involves some financial engineering. So I think that's like one way that people are approaching it. And there's just, I think your question actually speaks to my broader point, which is that there's so much financial engineering to be done in this space, that you have that method, you have things like securitized token offerings like STOs, and then you have things that are purely synthetic. So I think there's a lot of space to
Yes,
grow.
right. I mean, my question was like, do you imagine that like really with Ethereum we can build such thing, or we will need to really go with different platforms, different systems?
Open question. I would love to actually continue this conversation because I know we're over time, but let's continue this later. Okay, thank you so much.